Okay, for today, it's called parent functions and domain and range. Oh my gosh, one of the most important lessons of the year. So let's just get into, what do you do if they say f of something? Well, they're saying to take -2 and stick it into the equation. Pausing for a second. All right, so back to, we're going to stick -2 into the function, and then that goes here, but it doesn't really do anything. It just says f of -2. This is where something actually happens, -2 squared, which is different than if there wasn't parentheses. See, a lot of people don't think that these parentheses even matter. They're like, you just do -2 and you square it. Actually, that without parentheses is -4. But because there is a parenthesis, anytime you're doing something goes in a variable, there's a parenthesis there. Then that means +4. How many of you had +4 before I even said it? Okay, good. Any questions about that? So it's like there's an empty parenthesis there. Same thing with putting in a 0. It's like there's an empty parenthesis, but in that case, 0 squared either way, it's going to be 0, whether or not you had parentheses. So this one was 4, this one's 0. The next one, you're going to stick a 2 in the equation, and then that becomes 2 squared, which is 4 again. Notice, we just found 3 points on the equation. I want you to process that. This point right here was -2, 4. X was -2 and Y was 4. Would you please make the other 2 points right there? EJ, what's the next point? What's the X? So 0, comma. Can't see the board?
0.
Okay, and then this one. Ian. In the front row. 2, comma. 4. There we go. And that's 3 points. Do you get that you could just make a whole bunch of dots on a graph, and then anybody can tell where it is? If I make a bunch of these dots and I graph them, anybody'd be able to tell where it's going to go next. Do you get this is one of those parabolas? It's going to go like that. You just have to connect the dots. If I gave you a few more dots that were here and here and here and here, it would make it super obvious. But basically, you just need to get points. So if I give you a graph like y equals x to the third, and you don't have any clue what that looks like, I bet you there's somebody in here who does. But if you didn't have any clue what it looked like, as soon as I graphed these points, can you kind of tell that, well, duh, it's going to go like this then? That's what the graph looks like, because you can see where the dots are. So how do you get dots for a parent function? You pick any x you want, and you make an xy chart. So, for example, I'd like you to put in -2, -1, 0, 1, and 2. I want you to put in those 5 points. I'm going to pause for a second. Well, you put those numbers into x to the third. If you don't get what I mean put -2 here, and then see what you get. And then put in -1, and then put in 0.
-16.
2 to the third is not 16, though. It's 2 times 2 times 2. It's -2 times -2 times -2. Negative what?
8.
-8. There we go. A whole bunch of wrong answers were given until we finally came across -8. Okay, now we're going to put in -1 to the third. That means -1 times -1 times -1. Who had -1? Good. Okay. How about you put in 0? Well, anything 0 times 0 times 0, it's just going to be 0. And then if I put in a 1, Amelia, what's 1 times 1 times 1? Yep. And then if we put in 2, 2 times 2 times 2, 8. And I happen to have already graphed those. See? -2, -8 is this one. That's that point. -1, -1. That's that point. 0, 0, I think you all know that's there. 1, 1, that's there. And 2, 8, that's there. See, if you just graph enough dots, then it becomes obvious where this parent function lives. But now you need to memorize it. X to the third, we shouldn't have to do all that work every time. You should be able to just go, oh yeah, it looks kind of like that. That's x to the third. All right, so which are the ones I expect you to know? I expect you to know x squared, absolute value of x, just regular x, and the one I just did, x to the third. All of those you should just be able to be like, yeah, I know that one. Here's x squared. I'm going to test you on again in a minute, so pay attention. That's x squared. This is absolute value of x. This is y equals x. And this is x to the third. Okay, there are a few others that we'd want you to know. The square root of x, I'm going to think of that as like a bonus one. And the square root of x looks like this. Maybe that's all of them. Maybe that's all I'd really expect you to know. Just take a second and memorize those. 1, 2, 3, 4, 5. Gotta know which one's which. Okay, so now it's test time. Everybody write down what these three are. That's A. That is B. And this one's C. Y equals this, y equals that, and y equals the other thing. Okay, so letter A, Avia. What do you say?
I said it was y equals, I don't know how to say it.
Okay, what does it look like?
It's like two lines of x in between.
All right, there you go. It's called absolute value of x. All right, and the letter B, y equals, Ian, you got this one? Nope, this Ian in the front row, I just pointed out. X to the 2, yes, y equals x squared. And then last but not least is C. Quinn, what do you get?
Square root of x.
Square root of x, very good. And let's say you forgot one. Let's say that there's one that gets put out that's like y equals x. And you're like, I don't know which one that is. You just forgot. And then you make an XY chart and you find some points real quick. Everybody please tell me what happens when you put in 0, 1, and 2. Just write them down. Because you get to pick anything you want, and those will be the easiest things to pick. And then, what do you get? Amelia, what happens when we put in 0? Yeah, y equals 0. What if it happens if you put in 1? Amelia? Yeah, 1, 1. And the last one, Megan? 2, 2. And then if you graph those, you'll very quickly be reminded 0, 0, 1, 1, 2, 2. Oh, it's that one. That's the y equals x function. So if you ever forget one, that's how you figure it back out. Is you take and make a bunch of points. And anybody, if you make enough dots, you'll be able to figure out which one it is. You know what I mean? If I only give you one dot, it's super impossible to know which one it is. But if I go, here's 3 dots, you'd be like, oh yeah, that's that square root one. Or if I make 3 dots that are like here, well, actually it's two different things. It could be the V shape, or this one actually could be the parabola. So how would you tell? You'd make 2 more dots. And if your other 2 dots are like here and here, you'll be like, oh, it's the parabola. Okay. So then the last concept I need to teach is something called the domain and the range. By this little machine, I want you to write the word domain here. Domain. And then I want you to write the word range here. Domain, range. The domains are the inputs, and the range are the outputs. And now, if I asked you what's the domain of the function, I'm really asking you what are the x values that you could stick in. And if I asked you the range of the function, that's like f of x, which is like the y values. So here's a picture. And here's a V shape. The x values, this is x. Do you get that this thing goes forever in both x directions? It like keeps going. Goes way to the left and way to the right. So the domain of this V shape, you just put a D. Everybody make a D and then an R, which stands for domain and range. The domain of this thing is negative infinity to positive infinity. The range of it is the y values. Remember how I said this was y? If you look at this V shape, does it go downward forever? No, it's got a lowest spot. The lowest spot is right there at 0, 0. So its range is from 0 to infinity. And the reason I made it a bracket is because it touches 0. The function actually hits 0 because if I made a list of the points, 0, 0 would be on the list. So this needs a bracket. All right, so that's it. That's everything I have to teach you, but I get you may not have totally understood that domain and range that I just did there. The range was this way. It's like how low to how high, and it went from 0 up to infinity. The domain was this way, and how far did the graph go that way? It went forever in both directions. So negative infinity to positive infinity. All right, so here is another picture. Everybody, please graph this one and put a dot right there. This one does not have arrows on both ends because you can't put in negative x values because if you look at it, it looks like this. And if you have negative x values, you're taking square roots of negatives, which is not real. So you can't have negative x values. That's why it's got a dot here. 0, 0 is the lowest it goes. So what's the domain? The domain is how far it goes in this direction. And it goes from 0 to infinity. And the range is how far it goes in the y direction, which is this way, which is from 0 to infinity. But I put a bracket. Oh, I should add a bracket on the other one too, because it touches 0. That domain is from 0 to infinity. Domains are x's. And the range is from 0 to infinity. Okay. So here's one last function. How far does it go for its domain, which is the x values? Goes forever this way and forever that way, which is negative infinity to positive infinity. How far does it go for its range, also known as its y values? Doesn't it go forever this way and forever that way? Negative infinity to infinity. Okay. Question.
For the previous one, what was?
Okay, wait, before we move to the previous one, does anybody have questions about this one? Okay, now I'll go back on this one.
Yeah, just.
Okay, so the domain there is the x values, which go this way, and this is the domain. And it doesn't go forever in both directions. It has a dot right there, so it goes from 0 to infinity. Range, that's this way. That's the range. And the range was from 0 to infinity also. All right, that's the hard thing for today. Making little functions, super easy. If they say y equals the square root of x and you forget what it is, you just make some numbers and you try it out and you go, oh yeah, if I put in 4, square root of 4 is 2, and if I put in like 0, square root of 0 is 0, and if I put in 1, the square root of 1 is 1, and if you graph those points, you'll see 0, 0, 1, 1, 4, 2. Oh, it's that one. That's not the hard part. The hard part is doing the domains and the ranges. So, we just did this one. Is domain about x or y? Say it. X. What's the smallest x value this ever does? 0. What's the biggest x value it'll ever do? Infinity. And then does it touch 0? Yeah, so you use a bracket on things it touches. Can you touch infinity? No. Whenever you think you got there, you didn't go far enough. So you can't touch infinity. The other one's range, which is about low to high. It's kind of like sometimes it freaks people out a little bit because you have to ask yourself how low it went first. What's the lowest this function went? 0. To what's the highest it ever went? It would go to infinity. Bracket, parenthesis. All right. So here is a function. Is it a function? Yeah, it passes the vertical, remember that one? Vertical line test. This passes the vertical line test. What's the domain? Does it go forever in both directions? No, it does not. It has dots. So the domain is left to right. So how far left does it go? Ashlyn, what's the furthest left this function goes? It says the x values. Yup. The furthest it goes left is -2. My pen is too big, so give me just a second. I gotta erase that. -2. And then to the right, how far to the right does this thing go? Forever? No. It goes to there, but that's got two things. It's got an x and it's got a y. The domain is about the x's. So it's 4. How many of you knew it was 4 before I even said it? Okay, good. Then the range is how low this thing ever went. Well, that black arrow, that's pointing to the lowest spot there is. What is the lowest spot it ever goes to? How low is this right here at this spot? Well, it's 4 comma negative 1. So then it's negative 1 is the lowest it went. What's the highest it ever went? Very good. Right there is the highest it ever went, which is 3. And I just realized I need brackets because it touches at all those spots. Infinities are the things you don't touch, and so they need parentheses. We need brackets around these. And it was a function, yes, because it passed the vertical line test. Domain is how far left and right. If I was going to make you like a cheat sheet for it, left comma right, and this is down comma up. From how far down to how far up. There's left, right, up, and down, right? So this is the left, right part, and this is the down, up part. Okay, so not quite done yet. We're close. Going to the green page, or blue page, whatever color that is. I think it's light blue. Is it a function? Nope, doesn't pass the what? Vertical line test. So this is a no. Domain. How far to the left and how far to the right does it go? I think that's right there is negative 3. I think that right there is positive 3. Negative 3 to 3. And the range? What's the lowest this thing goes? Right there, which I think is again negative 3. To what's the highest this thing goes? 3. And then I just made a mistake. Can you correct it? Brackets. I keep forgetting to put brackets. It's only infinities that you don't use brackets on for now until you learn this even better. But bracket on anything it touches. All right, I'd say it's lunchtime. Okay, we're back from lunch. So, it's about making functions, and if you don't know how to graph them, like I don't remember what the shape is, you just stick in an XY chart, you pick anything you want for X, like 0, 1, 2, maybe throw in a negative number, and then you graph a bunch of dots. That's easy. But domain and range is a weird concept for a lot of people. Domain is left to right, range is down to up. And that's opposite of what most people would think. So, is this thing a function? Yeah, passes the vertical line test. Is its domain, does it go forever to the left? If you extended this out, it would go forever to the left. Would it go forever to the right? Is it slowly moving to the right? Yes. So this one would be negative infinity to positive infinity. How about, does it go forever up and down? No. How about forever down? Yep, so it goes down to negative infinity. And forever up? No, it stops. And then you got to be really careful. This point right here, it has two numbers you could use. Let's say it's negative 1 comma 4. Let's say that's this dot right here. When you're using domain, you use the X. We are doing the range right now. So we should use the Y, and therefore the height of it. The highest that point and that function ever goes was 4. And then it touches at 4, so bracket. You can never touch infinity, so parentheses. Okay. That's domain and range. The range was from negative infinity, because it went way down here, up to the highest it ever went was 4. Does that make sense to you? Question? Yes. Yeah. If you're not sure of something, ask. All right. Okay. So, on to the next slide. This is a bunch of them that we want you to know. Y equals X just kind of goes straight across like this. X to the third, that's this official function. Absolute value of X is the V shape. X squared is a parabola shape. Square root of X, this looks too flat to me, square root of x kind of rises like that. And then this last one is 1 over x. I don't know if we're going to get that far, but the rational function 1 over x, today I'll just remind you, it goes like this and this, in case you see any like that. And that has asymptotes here and there. Okay, so if they asked you to graph y equals x, you'd put in all these points, and then you'd stick those into the function, and you'd find the answers. So like stick in -2, and you get y equals -2. Stick in -1, and you get -1. And then you realize, oh, they're just all copying the original one. There. And if you graph those, you'd really have to try hard not to figure out where it's going. Duh, it's just a simple straight line. It's this one. What's its domain? Well, how far left does it go? -infinity. How far right does it go? Infinity. So it goes that way and that way. There we go. And then the range? Well, how low does it go? This function would keep going forever. -infinity. How high does it go? Infinity. Next thing I want to just like remind you about is if you have an XY chart, positive infinity is way over there, negative infinity is way over here. This one's positive infinity and this one's negative infinity. If you were wondering, like, you keep talking about these directions. If you go forever up, you hit infinity. If you forever down, you hit negative infinity. If you go forever to the left, that's negative infinity. Forever to the right, that's positive infinity. And this is the domain direction. Both of these are domains. And this is the range kind of directions. All that make sense to you? If so, you've got homework, which is a single worksheet. I think it's even all just on one side, if I remember right. So let's get that out and start it together right now. So everybody find that worksheet. And numero uno. Megan, could you possibly pull up the first question of the worksheet? Just y equals x. Do you know what that one looks like? You draw it in the air with your finger? Yep, just goes like that. So it looks like that. Did they just want you to graph it, or do they want XY chart, or what do they want? Both? Okay, so then the XY chart, I personally would just stick in -2, -1, 0, 1, 2. Unless they don't need that many, in which case, if they don't need that many, I would just start with -1. But if they want 5 points, those are the logical ones. And when you stick in -2, you're saying y equals -2. And when you stick in x is -1, you're saying y equals -1. And there we go. And just make a list of them. 0 and 1 and 2. Okay. So I'm ready to just turn you loose on this worksheet, but I feel like maybe we should try one more. So let's look at problem 2. Lily, could you read me problem 2? Lily K.
Is y equals absolute value of x.
Excellent. And if I was going to do it, I'd probably make the XY chart first. Can you tell me, did they put in numbers on the X for you?
No.
Okay, then we get to put in -2, -1, 0, 1, 2. That's the big 5. It's all centered around the origin, and it'll make sense. Now let's drop in a -2 right here. Do you guys know that the absolute value of that is +2? So a -2 gives you +2. Gianna, can you tell me what to do with the -1? And then its absolute value of that, which is? Absolute values means that it's, how far is that from 0? 1. Good. How far is 0 from 0? 0. When you put in 1, a 1 goes right here. Absolute value of 1. Some people get confused that absolute value is like a sign switcher. It is not. It's a distance from 0. That's what absolute value means. So how far is 1 away from 0? 1. So they just always come out positive. The smallest they could ever be is 0. And E and K, the last one, when you put in 2, you get 2. And then when you graph this thing, it will be the V shape. 0, 0, negative 1, 1, negative 2, 2, 1, 1, and 2, 2. There we go. Then don't forget domains and ranges. If you had to do the domain and range of this is my last question. Domain is left to right. So what is the domain on this one? What's the domain on this one? Yes.
Negative infinity.
Okay. And what's the range on this one, which is low to high or down to up? Remember, you always got to start with high. Sorry, low. The lowest that it goes. What's the lowest that it goes? What's the lowest it goes? Well, right there. What's the low of that? 0. From 0 to what's the highest it'll ever go? It never stops. 0 to infinity then. Yes.
When it's in, I forgot what's.
Okay. When you get stuck on the worksheet, bring it on up.
Okay.
And that's all I have for you for the video for today.